Pay attention. Today we are going to talk about radiation. Okay. Please pay attention and note. The first and foremost thing that it is the fastest mode of heat transfer. It is the fastest mode of heat transfer. Okay. The next point which is important about it is in this mode, medium is not required. Let me write even more clearly. In this mode of heat transfer, medium is not required. Okay. This the light which comes from sun to earth, this travels in form of radiation. So in radiation, heat flows in form of EM waves, in form of electromagnetic waves. Electromagnetic waves. Okay. So in radiation, heat flows in form of electromagnetic wave. Okay. Good. Pay attention. Suppose this is some surface. Okay. Or you can say separating surface. Now heat is falling on it. This is incident heat. Okay. Now this incident heat can be reflected also, or this heat can pass. So this is transmitted heat. And this heat can get absorbed also. Absorbed heat. Okay. So basically, whenever heat is being incident at some surface, three phenomena may occur. Number one, reflection. Number two, absorption. And number three, transmission. Okay. So heat is when heat is incident at some surface, three phenomena.
Sir,
Yes.
can you please scroll up a bit?
Okay. Done.
No, sir, little bit.
Hmm.
Thank you, sir.
Okay. So number one is reflection. Number two is absorption. And number three is transmission. Suppose Q is the incident heat, or you can say Q naught. All right. QR is reflected heat. QT is transmitted heat. And QA is absorbed heat. So what we can write is Q naught is equal to QR plus QA plus QT. Okay, where Q naught is the incident heat or total heat basically. If we divide, this is equation 1. So if we divide this by Q naught upon Q naught is equal to QR upon Q naught plus QA upon Q naught plus Qt upon Q naught. So Q naught upon Q naught is 1 is equal to QR upon Q naught is R plus A plus T. Okay, please note. Here R is equal to QR upon Q naught, and that is called reflection coefficient of medium or substance. Okay. A is equal to QA upon Q naught, that is absorption coefficient. T is QT upon Q naught, and that is transmission coefficient of medium. What do we mean by absorption coefficient or transmission coefficient or reflection coefficient? Try to understand. If I give you some money, okay, suppose. So what your nature is, you keep some to yourself, some you throw back, and some you let us go through you. I'm talking in very vague term, but mm, take it that way. So when I gave you some money, what you did, you threw some back. So you gave it back to me, some amount of that. I said, okay, that is reflection basically. Some amount you kept for yourself, that is absorption, and some amount you allowed to go through you. That means you gave to some of your friend, right? So this is the transmission. This is the transmission, and all three are important. Mind it. Okay. The important thing, if you notice, is the sum of reflection coefficient plus absorption coefficient plus transmission coefficient is always 1. So this is important. You can write it as star point. Sum of reflection coefficient comma absorption coefficient and transmission coefficient is always 1. Is always 1. Okay, or unity. Any doubt, any question? Good. Let us move further. Now, keep one thing in mind, everyone. See, if some surface is there, okay, and if that surface is reflecting 100% of its light, if that surface is reflecting 100% of the heat, okay, falling on it, will that surface be getting heated? No, because it is reflecting 100%. All right. Similarly, if heat is falling on some surface and it is allowing 100% of heat to pass through it, then will it get heated? No, because it is 100% allowing the heat to pass through it. Okay. If only the surface or medium is absorbing some heat, then only the surface will get heated. Okay. So these coefficients play very important role in how the surface is going to behave. Okay, good. Please pay attention. There are small terms actually. We'll be talking about them later. Let us first talk about one simple thing that is called black body. That is called black body. Okay. So what is a black body? Black body is an object which absorbs all the radiations falling on it. A black body is an object which absorbs all the radiations slash heat falling on it. Falling on it. Okay. So this is a specialty of a black body. What it does, it absorbs all the radiations falling on it. Okay. Now, in day-to-day life, so basically in our common life, no object is a perfect black body. No object is a perfect black body. Okay. In day-to-day life, or you can say common life, no object is a perfect black body. Now, what is meaning of this statement? This statement means that no object can 100% absorb radiations falling on it. That is, no object, no object can absorb 100% of radiations falling on it. Okay. You know why? Because what is the reason of this? If suppose, if an object is not reflecting the heat, okay, light is also a form of heat. If an object is not reflecting the heat, or you can say light, you won't be able to see that object. If you are able to see any object, that means that object is reflecting heat or light. Okay. If an object is a perfect black body, that means it is 100% absorbing the radiations falling on it, then that object won't be visible. Then that object won't be visible. So in day-to-day life, charcoal and charcoal and lamp black is basically kajal. Charcoal and lamp black are very close to be a are very close to a black body, or you can say perfect black body. Very close, but they are not. Okay. So charcoal and lamp black is quite close to be a perfect black body, but these are not perfect black bodies. All right. Okay. Is there anything in nature which is a perfect black body? Yes. Black holes. Black holes are or can be considered as black holes can be considered as a perfect black body. Okay. But the problem is you don't find them in day-to-day life. You don't find them in day-to-day life. So black holes can be considered as a perfect black body. Do you know why black holes are a perfect black body? Because even light cannot escape from it. Okay. So I am writing the reason. Gravity of black holes, gravity of black holes is very high. Okay. Or gravity in black holes is very high, both have same meaning, such that even light cannot escape from it. Even light cannot escape from them.
So you are on mute. So someone is muting us, sir.
Now tell that person to do all these stupid things. So fairy is black body. Fairy is black body. Can you hear me now?
Yes, sir.
Okay, good.
Yes, sir.
Good. So fairy is black body. Pay attention.
So what is C in that previous formula?
C is speed of light.
Okay, sir.
Yeah. Universally, C is reserved for speed of light. Okay. If nothing is mentioned explicitly, then be assured that C must have been used for speed of light. Yeah. So I'm not able to. Okay. So basically there is a small opening, very thin opening. Now why very thin opening? So that through this opening heat can enter in this system. Now when heat is entering at this system, there is a reflector. There is a reflector kept here. So suppose that heat entered, okay, in a straight line. Now that heat will be reflected here, then here, then here, then here, 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 and so on. Okay. All right. So this is a reflector. Now this inner part of these two spheres, this will be insulated. This will be insulated. Insulated means heat cannot pass through these two spheres. So as there is no scope for passage of heat, it cannot go through this way due to insulation. Okay, so this is insulation. Now inner walls of this are painted by charcoal. Inner walls are painted by charcoal. Why painted by charcoal? Because charcoal is a good absorber. Okay. So now try to understand what is happening in this whole process. Due to this very small opening, a very little amount of heat is being able to enter in this. The purpose is that any amount of heat which has entered into the sphere, okay, which is actually Faraday's black body, it should not be able to come out. It should not be able to come out. So you can see that the blue color light is basically showing you the heat which is entered into this. When it entered, then due to reflector, it is reflected because reflection occurs as per law of reflection. And what is that law? Angle of incidence is equal to angle of reflection. So that reflection is continuously happening inside. Okay. In each reflection which is happening inside, as the surface is charcoal painted, heat is getting absorbed in every reflection or during every reflection. So after every reflection, the intensity of heat which is left with the ray is decreasing, 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 decreasing. Okay. As I told you that the space between the two spheres is insulated, thermally insulated basically. So heat cannot pass through that way. So basically there is no way left for the heat to come out of this black body. So this was created by Faraday. That's why it is called Faraday's black body. Okay. So please draw the diagram and then we are going to write a little bit about it. Please note. Noted? Noted? Okay. Now let us move further. Actually, there are some laws of black body radiations. Okay. So please pay attention. Laws for black body radiation. So suppose there is an object Hmm. This is an object of any shape. This is an object of any shape. All right. And its surface area is capital A. And its temperature is T naught. Okay. Its temperature is T naught. So please pay attention. In the given situation, in the given situation, an object of surface area A and temperature T naught is shown okay, if if dq by dt if dq by dt is the rate of heat emitted, then if dq by dt is rate of heat emitted, then okay, so dq by dt is proportional to area, equation number 1. Okay, dq by dt is proportional to temperature, fourth power, basically fourth power of absolute temperature. This is very important. Which temperature is this? Absolute temperature. Okay, so dq by dt is proportional to T naught to the power 4. If you club these two, okay, then dq by dt is proportional to a t naught to the power 4. All right. And when you remove this proportionality, then you get dq by dt is equal to sigma a t to the power or t naught to the power 4. Here sigma is a constant called Stephen's constant. Here sigma is a constant called Stephen's constant. Stephen's constant. Okay. So there was a scientist named Stephen who worked on this, and based on this, the constant is called as Stephen's constant. Okay. So please note. Please note. The value of sigma. The value of sigma is 5.67 into 10 to the power minus 8. So how you can remember it? 5, 6, 7, 8. Okay. So what exactly this law says? This is law for a black body radiation, or Stephen's law for black body radiations. So please note. Stephen's law for black body radiation. Okay. So what this law says? For a black
by dt proportional to t naught raised to 4.
Yes.
Okay, sir.
Yes. Okay. So please write for a black body. For a black body, rate of heat emitted. Rate of heat emitted is proportional to the product of is proportional to the product of its surface area, and fourth power of its absolute temperature. Of its absolute temperature. Okay. Okay. So basically dq by dt is proportional to a into t naught to the power 4. Sigma is a constant. So sigma is not going to make any difference in terms of, if you change the value of area, then dq by dt will change. If you change the value of temperature, then dq by dt will change. But if you are making sure that a into t naught to the power 4 is remaining constant, then your dq by dt will not change. Okay. All right. So this was for the heat radiated by a black body. Now suppose if object is not a black body, then if object is not a black body. So if object is not a black body, right, then dq by dt is equal to E sigma A T naught to the power 4. What is E here? here small e is emissivity of the substance of object. Okay, here small e is emissivity of substance of object. Okay, please note. So the only difference is for a black body E is 1, for a normal object E is not 1 and its value will be between 0 to 1. Okay, so you can write for a black body E is equal to 1. For ordinary substance E should be greater than 0 but less than 1. Okay, so emissivity of an ordinary substance is between 0 to 1. The more it is going closer to 1, the perfect the object is going to become a black body. Okay, let us solve a question. For an object, of area capital A and temperature capital T, the rate of heat emitted is Q naught. Okay, the value is given as Q naught. Find rate of heat emitted. Find rate of heat emitted if number 1 temperature is doubled, number 2 area is doubled, number 3 both are doubled, both temperature and area are doubled. Please find and give me answers. Rishikesh, you need to give your answer in terms of Q naught. Rishi, you need to give your answer in terms of Q naught. Okay. So pay attention. So there is an object of area A and temperature T. So Q, how they have defined Q naught is equal to E, we don't know which substance is there, okay, into sigma into A into T naught to the power 4. This is equation 1. Q naught is E sigma A T naught to the power 4, right? Now, first part, temperature is doubled. So Q1, I am saying Q1. So temperature, if it is doubled, then E sigma A 2 T naught to the power 4. And 2 to the power 4 means 16. So it will be 16 E sigma A T naught to the power 4. So basically it is 16 Q naught. Basically it is 16 Q naught. In second case, only area is doubled. Q2 is equal to E sigma 2A T naught to the power 4, and that becomes 2 times E sigma A T naught to the power 4, and that will be 2 Q naught. That will be 2 Q naught. Okay. And after that, in third case, Q3 is equal to E sigma. Now both are doubled. This becomes 2A and this is 2 T naught to the power 4. So 16 into 2 will be 32. E sigma A T naught to the power 4, and that will be 32 Q naught. Basically 2 to the power 5. Okay. Okay, everyone. Any doubt, any question? Good. Good. Next question. Question. For a spherical object of radius r, for a spherical object of radius r and temperature T degree Celsius, the rate of heat emitted is Q naught. Find new rate of heat emitted if radius is made half and temperature is made 2T degree Celsius. Please solve. Please solve. I want all of you to read the question carefully. I want you all to read the question carefully. Read carefully. Okay, everyone. Let me solve this and tell you that what mistake you are making. Okay. So for a spherical object of radius r and temperature T degrees Celsius, the rate of heat emitted is Q naught. So Q naught is basically E sigma A will be 4 pi r square into T plus 273 to the power 4. Why T plus 273? Because here temperature is given in degree Celsius. Here temperature is given in degree Celsius. And unmindful people, they don't pay attention to details. They don't pay attention to details. Now, in new scenario, Q new is equal to E will be same because substance is not going to get changed. Sigma will be same because sigma is a constant. 4 pi, radius is halved. That will be R by 2 to the power 2 into. Now temperature is made 2T degrees, so this will be 2T plus 273 to the power 4. Okay. Okay. This question was deliberately given because I know that how students behave. They don't read things, read questions carefully, and then later they cry, "Sir, I solved it correctly, sir, but I read the question incorrectly, sir. Sir, मैं क्या करूं, sir?" बेटा, question ठीक से पढ़ो. Okay, so Q new upon Q naught is equal to E sigma 4 pi. Let me write E sigma 4 pi r square upon 4 into 2t plus 273 to the power 4 upon E sigma 4 pi r square t plus 273 to the power 4. So if we cancel E sigma 4 pi r square, then the question is all almost over. Q new is equal to Q naught into 2t plus 273 to the power 4 upon 4 t plus 273 to the power 4. Okay, that is the answer. That is the answer, everyone. Understood? Understood, everyone? Say yes, sir.
Yes, sir.
Good. Good. Okay. Now, just to give you a little bit feel of this chapter, suppose there are two surfaces. One surface is polished and one surface is rough. Okay. For which surface the rate of heat emission will be more? We have two surfaces, one is polished and one is rough. Okay. You can consider them as two spheres. One is polished sphere, one is rough sphere. For which surface rate of heat emitted will be more? For polished one or for rough one? Tell me. Quiz question. Quiz. Tell me, for which surface rate of heat emitted will be more? Arad is saying same or rough one because more surface area. You have given two answers in the same thing. In one answer, you have written two things, Aradhya. Okay. Let me tell you. Okay, Arad is saying same. Amod is saying polished. Yash is saying same for both. Let me tell you everyone. Answer will be more for rough one. Why? Because rough surface will have more surface area. Okay. When you polish it, what you are doing? You are removing the wear and tear, and in that process of removing wear and tear, what is happening? Surface area is reducing. Surface area is reducing. So for rough surface, the rate of heat emitted will be more as compared to polished. Keep that thing in mind. Keep that thing in mind. Okay. All right. Next question. For a star, and stars can be treated as black body for these calculations. Okay, I'm telling you. So for a star of radius r, for a star of radius capital R and temperature 2000 Kelvin, the rate of heat emitted is Q naught. Find rate of heat emitted. Find rate of heat emitted for another star Find rate of heat emitted for another star of radius 2r and temperature 2500 Kelvin and temperature 2500 Kelvin. So everyone please pay attention. Q naught is equal to E sigma A 4 pi r square because stars are spherical into 2000 to the power 4. This is equation 1. Now Q nu is equal to E sigma, radius is doubled, so that will be 4 pi into 2r whole square into 2500 to the power 4. So temperature here is given in Kelvin. So you don't need to worry about this thing. Now simply divide and get the answer. Okay. Dividing 2 by 1, get answer. Okay. So that is enough for today. We'll study further in the next class. For stellar
Excuse me,
higher.
sir.
Yes.
Sir, E will be same for the both the stars.
Yes, I told you for a black body, we treat star as black body. For black body, E is 1. Okay.
Okay,
Stars
thank you.
can be treated as black body. All right.
Okay, sir.
Okay.